it's towards the end of the day and this is take 4. I'm hoping this last video will help explain that chart that was on the previous slide. It's basically to show you what happens to the equilibrium expression and to the constant when I do something to one of my chemical processes. So this was our video from before, and we found that the equilibrium constant for this forward reaction, the synthesis reaction of hydrogen and iodine to create 2HI, was 10. No units, units canceled out. What happens if I reverse the process where it turns into a decomposition? So here I've rewritten the chemical equation so that now my products are H2 plus I2 and my reactant is 2HI. So basically I flip things over. So now when I go through and solve this, you're going to see that the equilibrium constant is now going to be the reciprocal of the one we found before. I'm going to call this KC2, where the other one was KC1. And my hydrogen had a concentration of 1.4. My iodine had a concentration of 0.10. My HI had a concentration of 1.2, and I'm still going to square that. And when I solve this all out, I get 0.10. Well, 0.10 is the reciprocal of 10, because if I took the reciprocal of 10, that's 1/10, otherwise known as 0.10. So I can say that the second equilibrium constant is going to be 1 over the original equilibrium constant, which I'll call C1. Now what happens if I decide to cut the concentration of my reactants and products in half? I can express this by cutting the coefficients in half in my balanced chemical reaction. And by doing that and using the original concentrations, I will find that my new Kc value is going to be the square root of the original, or C2 in this case. So my new expression is going to look like Kc, and we'll call this one 3, is going to be the concentration of H2 to the 0.5, concentration of I2 to the 0.5 over the concentration of HI, and it's not raised to anything this time. By having that coefficient, that will do what I need to have happen to the concentration where I halved it. So I use my original concentrations. My H2 was still 1.4 to the 0.5. My I2 is going to be 0.10 to the 0.5, all over the HI, which is going to be the 1.2. And when I solve this out, I obtain a value of 0.31. Again, no units. So if I take the square root of 0.1, which is what I got on the previous slide here, I will find that is going to be 0.31. So to get my third equilibrium constant, when I half the concentrations, all I have to do is take the square root of Kc2 in this case, which was 0.1. So that table will do a really good job of showing you a shortcut of what to do when you have different things that happen to chemical reactions. The last one we will get into when we start talking more about energetics. Hopefully this